You sit near the fire, feel its warmth, smell the wood smoke, hear a slight crackling. It seems that you can look at it forever. The way its coals flicker and bright sparks fly into the sky. But do you think about what you are looking at, what warms you? Fire is not a solid substance. This is understandable even to a child. But it's not liquid either. It tends upwards and it seems that it looks more like gas, except that it can be seen. But from the point of the view of science, it differs from gas, because it can remain in its state indefinitely, and sooner or later the fire goes out. There is a misconception that this is plasma, the fourth state of matter in which atoms are deprived of their electrons. It, too, like fire, does not have a stable state on our planet. Plasma is formed only when the gas is exposed to an electric field or is heated to a temperature of thousands and tens of thousands of degrees. But fuels such as wood and paper burn at a temperature of only a few hundred degrees, much lower than this threshold. What is fire really? So, fire is not a solid, not a liquid, not a gas and not a plasma. What else can we do? Probably not to consider fire as matter at all. This is our sensory perception of chemical reaction called orange. In a sense, fire is like leaves changing color in autumn, the smell of ripening fruits, the flickering light of a firefly. All these are sensory sensations that tell us that some kind of chemical reaction is taking place. Fire differs only in that it simultaneously engages many of our senses, creating a range of sensations that we expect to see only from something alive and material. When the fire gains heat, the water vapor and carbon dioxide generated during orange dissipate. Losing density, they rise up in a column. And the expansion, and dispersion, and vaporization of gases, all this is caused by gravity, which, in addition to everything, gives the fire a characteristic conical shape. Without gravity, molecules do not separate in density, and fire has a completely different shape. What is the hottest color of fire? We see all this due to the fact that light radiation is generated during the combustion process. Orange molecules emit it when they heat up, and its color depends on the temperature of elementary particles. The hottest fire is white or blue. The type of molecules inside the fire can also affect the color. For example, all the carbon atoms that have not reacted form small particles of soot, which, flying up, emit yellow-orange light. The one that is associated with the bonfire in the first place. Substances such as copper, calcium chloride and potassium chloride can also add their characteristic shades to the gamut. A bonfire is not only light, but also warmth. It maintains the fire by heating the fuel to or above the ignition temperature. Eventually, however, any bonfire, even the largest and hottest one, goes out. The fire, having emitted a farewell smoke, hides and disappears. It's as if he never existed.